Welcome back the students for this UGC lecture series on laser physics and the Swayam portal. Today we are going to see some more applications of lasers. I had been giving fairly detailed account of laser communication systems. In that I had shown how infrared laser and fiber optic, a very good combination, dramatically changes the communication world. When I say dramatically, it is really dramatic, because the end result is a small villager, an illiterate villager in a remote corner of India can have a mobile, a smartphone in his hand. All that he needs to know is to use the number 1, 2, 3. The number will not be like 1, 2, 3, it may be 7, 8, 9, 1, some would be given in his paper, and if he knows how to count the numbers, that is all what he needs. Just he can press this one, then immediately he will have some response from the mobile, and then he needs to touch some point. At the other end of the point, he can see his son or a daughter or a grandson or a granddaughter far away somewhere in the northern states of Canada, Alaska or Colombia or any part of the world, Fuji, all Hawaii, these are all far, far away, few thousand miles away, and he can hear the music, he can hear the voice, and he can feel almost the touch of his small grandchild. All these are possible because of the so called 5th generation, or at least the 4th generation communication link, which was built very widely throughout the world, and the backbone of this kind of communication network is a laser and the optical fiber, which I have already explained. All that I am going to show now is, if you go home today after this lecture, go home, you would have your Wi-Fi or a modem in your home, or if you are living in a big flat somewhere in some corner of the big flat, they will have a big Wi-Fi which will contain a modem. Now, in that, if you go anywhere, take the help of a technician, you will see an yellow fiber like this one. This is the so called optical fiber meant for bringing 4G pulse code, pulse optical code. The light is a messenger, the code is a message, and the laser beam will be launched at one end of this one, and another end. In this end you can see only the laser beam, you will not see the code, but this will be connected, to one end which brings all the information. This will be connected to another end in your own modem, which will receive all this one and discard the light and take only the message, which will be in few gigahertz or few megahertz, or which will take the video and audio signal. And I want to show you with this is a very powerful green laser. If I just show this laser in this one, you can see the light that passes through and comes out through this optical fiber. Now, look at this one. I have already explained about optical fiber. It has been twisted. It can just be rolled in anything. Still, you will be able to see the light. Most of the light coming here, going there, will come out almost with the 80 to 90% efficiency. That is a property of optical fiber. All this I have already explained. Now, in this lecture, the next important lecture, I am going to show you about another major application, which is the medical applications. Before we go into the medical application, I must just build up a background that laser is a high bright source. What do you mean by high bright source is you have plenty of photons coming through a certain source, and if you could put all these photons on certain object, particularly a certain chemicals, light will produce photochemical effect. This particular photochemical effect, that is a chemical reaction initiated, maintained by light. If there is no light, the chemical reaction would stop, remember. So, that is why we call it the photochemical effect. It, remember, photon is not acting as a catalyst, no, it is a combined effect of photon plus chemical put together leads to certain kind of specific reaction. That kind of reaction is called the photochemical effect. This has again wide range of application. I would just take only two of them. First one is isotope separation, the other one is cancer therapy. Cancer therapy, in this case we are going to talk about photodynamic therapy of cancer employing laser. Before we go into that one, isotope separation. In this particular case, photochemical reaction is made to take place only for one isotope, and then it is separated out. Now, before we go into what is that advantage of isotope separation, why we need isotope separation, let me give the background. Many of you would have known that isotope means a chemical which has the same number of proton, but different number of neutron. For example, for hydrogen, if we have one electron, one proton, it is the first type, the simplest hydrogen. This is the most commonly occurring hydrogen. But there is another hydrogen which is called heavy hydrogen, which is called deuteron. In that case, you have one electron, one proton and one neutron. Then in the nucleus, you have got two nuclear particles. In ordinary hydrogen, which is abundant in nature, you have one electron around the nucleus, running around the nucleus, very much similar to the earth running around the sun. In the nucleus, you have only one proton. That is the most commonly available hydrogen. In some hydrogen, which is called isotope, you will have a proton and a neutron. This is called the deuteron. Not only that, there is another type of isotope which is called triton, where you have one proton and two neutron, which is far rare, very rare. Now, all of them are possible. Now, this is about hydrogen. Keep going through all the rows and columns of periodic table. Let us come finally into uranium. There are two types of major isotopes. One is uranium-235, the other is uranium-238. Out of this, uranium-235 is the most important, which is used for, which is a fissile material, which is used for all nuclear reactors and also for atom bomb. And uranium-238 is an isotope of uranium, but in nature, fortunately, we must say fortunately, uranium-238 is more abundant than uranium-235. But for all of our nuclear reaction, we want uranium-235. So, how to separate out uranium, fissile uranium, discarding unwanted uranium-238? This is the question. This is called isotope separation technology. Before the laser came in, what was used? They used very high quality, high speed centrifuge. You know, the centrifuge is a machine which rotates, that is all, very simple. Centrifuge is a machine which rotates. When it rotates, the heavier one always will go down the settle, and the lighter one will always go to the top. This is something which you can always do if we have cup of ice, or if you have cup of cereals, or you have cup of groundnut along with ice cream, along with water. If you are interested only in the groundnut, all that you have to do is just stir it, stir it, stir it. After some time, you will see the heavier groundnut will come down to the settle down to the bottom, and the lighter one may be floating up, and water will be at the top. This is as simple as this one. This is the centrifuge. Then, if you want to have the heavier alone separated out and the lighter one taken away, you must use a heavy high speed centrifuge, and then they separate out these two. This technology is used even now, but it is not so efficient. In this kind of situation, people have used lasers for isotope separation, because uranium-235 fissile material is very expensive and very useful and very dangerous. All the three are true. For that, the idea that people have used is this kind of multi-photon excitation. I have just given the schematic of this one. It is something like this one. This, you take a molecule, or you take a pure uranium. Let us simplify this one. Let us take a pure uranium, in which you have uranium-235 and uranium-238. Because uranium-238 has few more neutron in the nucleus, the atomic energy level will be slightly different. The kth level will be slightly different. Then similarly, L energy level also will be slightly different. Like that, there will be small differences. Now, all that you have to do is, the difference is of the order of 1 or 2 nanometer. For simplicity, I say, let me say, the isotope 2 and the isotope 1, they have a separation of only 2 nanometer in the kth energy state, the bottommost energy level. This is just for simplification, I give this example. Then all that I need is a high power laser, tunable high power laser, and it should be a pure tunable high power laser. Why we say this is, if it is a tunable laser, I can just tune the frequency in such a way I am able to excite isotope 1 alone from one energy level to another energy level. Let us say from the ground energy level to the first excited state level, I must be preferentially very carefully excite the isotope from the ground level to isotope 1 level. I do not disturb isotope 2 at all. Then I send another photon. This photon will kick the atom at the top of this one. It will be kicked from here to another higher energy level. From there, it will be kicked to another energy level. At some point, that particular isotope alone can be ionized. Once it is ionized, you can apply a voltage or a magnetic field, take it away. This is what you mean by multi-photon excitation. This multi-photon excitation of precise frequency, tunable frequencies are available using argon ion pumped dye laser or excimer pumped dye laser, or there are so many methods of producing dye laser. Make use one of them. Fortunately, with the dye laser, you can have precision technique of choosing a wavelength of 541.3333 nanometer. Such an accuracy is possible. And then if you have plenty of photons, you have to focus on the isotope and separate or kick out only one kind of isotope to higher energy level, still higher energy level. Eventually it gets ionized, which is then after, once it is ionized, you apply electric field or magnetic field, take it away. That is all what is being done. This has very great application in atomic and nuclear reactors and also weapons also. We would stop at this one. Another important application of this isotope is the medical application. Some of these are used for variety of medical nuclear medicine. Yeah, this is called nuclear medicine. You give certain type of food eaten by the patient will pass through every part of the body, and wherever there is a tumor, a particular isotope will get stuck to this one. That particular isotope can be easily traced because it is going to produce radioactivity. That kind of nuclear detection or nuclear diagnosis of cancer detection also is possible. That is based on nuclear activity. Laser is not coming into the picture there. So, I am not going detail into that one. With that, we will stop about isotope separation employing lasers. The same very kind of tunable wavelength laser of very high energy has been used for cancer therapy, which we are going to see immediately. What we mean by cancer therapy, in this case, people have used different type of cancer to do therapy. Therapy means you try to make use of laser or any other drug or any other medicine to suppress the disease without doing any kind of surgery. If we cut the tissue and throw it away, it becomes a surgery. If we do not cut it and suppress it, it is called a cure it, then it is called a therapy. You can make use of laser for all the three purposes: detection of cancer, therapy of cancer, and also surgery of cancer. All the three are possible, and I would go into detail of this particular technique alone. It has a wide range of application. This particular technique has become the fourth dimension of cancer management in many hospitals. Why we call this a fourth dimension is this. Perhaps I should add a few words about what is a cancer. Then only the whole thing will be in proper perspective. Cancer is an autonomous, uncontrolled growth. What we mean by that is, our body has plenty of cells, millions and billions of cells. We are all made of cells, and the cells are continuously regenerating, dying, and new cells are being born. So, what I was half an hour ago is not what I am now. I have changed it. This is true for you or anybody. This kind of cell dying and cell regeneration is a normal process for every living being, including the tree or dog or monkey or human beings. So, but what happens is, in certain part of the tissue, the cells forgot or cells lost this kind of proper cycle, and they keep on growing in certain part of the body due to certain unexpected development or due to misuse of the body by smoking or over drinking, by certain, there are so many reasons for that one. One of the most important reasons is smoking. Smoking irritates the skin, irritates the cells. After some time, the cells will keep on giving the warning, giving the signal, then they will start rebelling. When they start rebelling, then the cells will not follow the general rule of the body, general rule of the human body. They would start growing all by themselves without following the common rule. This is something like the rebels in any country. This is what you mean by autonomous growth. Autonomous means they have lost the control. The body has lost the control over those tissues. That kind of tissues are called cancer tissues. Second point is, since they have lost that control or order, they will grow and grow. Not only that, they will be able to invade through the bloodstream and go to other part of the body and start growing there. This is something like a terrorist. A cancer is a terrorist in the body. They have autonomy, they have their own rules, they don't obey the general rule, and they can move from one place to another. So, it is very difficult to destroy the cancer cells unless everything is taken care of at a very early stage. So, that is why the doctors say early detection of cancer is the most important thing. Once that is done, when the cancer growth is very localized, it is possible to completely remove it and throw it or destroy it. For that, there are many methods. The first most possible method is just they will do surgery if it is possible, or radiotherapy. Then third one is chemotherapy. Surgery means, imagine that somebody has got cancer in the finger, for example. Just take an example. If somebody has got a cancer in the finger, cancer comes most often in the food tract, that is starting from the mouth, throat, throughout the body, wherever the food is going on, or wherever you inhale air, or wherever you drink water. Why I give all this important information is, for 50 to 60% of the cancer are due to externally, it is not inherited. There are few inherited cancers also, but it is mostly due to external, unexpected, unwanted influences by viral infection, or due to misuse of the body by smoking and drinking. These are many things. Okay, we will not go beyond that one. Now, where laser come into the picture, if somebody has been smoking for a long time, and if he has cough, repeated cough, he may have ordinary problem, chest problem, or he may have cancer in any part of the lungs or the heart or any part of the body, any part, quite possible. Then one such test is just to take the blood. If there is a cancer in any part of the body, blood will be circulating everywhere. There could be cancer cells. Not only that, there could be certain biomolecules produced in excess by the cancer tissue. Imagine that particular person has a cancer in the stomach or in the lungs. He coughs and coughs, he is becoming lean. Imagine that way. Then, since the cancer growth is there and the blood is going through every part of the tissue, it would carry certain biomolecules which are released by normal tissue as much as by the cancer tissue. In the cancer tissue, a certain type of biomolecule will be excess than the normal. Now, if you take that kind of blood, put under certain spectroscopic instrument, shine laser, then the laser beam will interact. Remember, the laser beam will interact with the biomolecules of blood. For example, there are certain proteins like tryptophan, NADH, and also porphyrin. All these are very common biomolecules in the blood of everybody. Then what happened? Those who have got cancer in the lungs or in the stomach, the tryptophan level is 2 times less than the normal, but porphyrin level is 3 times more than the normal. Suppose I come across, I use laser or light and I come across such a blood, I could say very definitely that this particular person has got a cancer in some part of the body. Most probably, since he is coughing, he is finding difficult to breathe, most likely he has got a tumor in the lungs or in the stomach. Go and have further examination. So, it starts as a first starting point. We always say this is the first barrier against the invasion of cancer. You could immediately say there is a very strong indication that this person can have, remember, nobody would say he has got a cancer. He may have cancer, he needs further examination and treatment. This is where cancer diagnosis employing laser comes to the place, and this has played a vital role, and in that particular domain I have done the pioneering work throughout the world. We will see more detail later. Thank you very much.